Welcome to Chapter 1, Section 6. This is relations. So, we've worked on solving equations with one variable and also two variables. As we move forward, we're going to look at how do we represent things called relations, and we'll look at some graphs of relations. So, it's really just how we look at two different variables, how they interact with each other. So, some vocab to think about. We have a coordinate system, that's just your XY plane, coordinate plane, same thing. We have X and Y axes, so X being your horizontal, Y being your vertical. We know the origin is the center of that plane. We'll talk about ordered pairs and some specific X and Y coordinates. With a few others, we know domain and range are important, and we'll talk about independent and dependent variables. So, example 1a. It tells us to express the relation, given here, as a table, a graph, and a mapping. So we see there are three things here that they're asking us to do. Write a table, do some sort of a graph, and a mapping. So for the table, we want to list the x coordinates in the first column and the y coordinates in the second column. So table, we know what a table looks like. It's just this kind of an image. So you need a column of your x values, a column of your y values, and then you plot the ones that go together. So when x is 4, y is 3, we get this point. When x is -2, y is -1, we get this point. When x is 2, y is -4, we get that one, and you see how this works. So there's our table. We've got the first part down. Now we need a graph. So our graph tells us to plot those ordered pairs on the coordinate plane. So if we go back, we saw our first point 4 for x, 3 for y. On our graph, we go over to 4, 1, 2, 3, 4, and 3 for y, 1, 2, 3, and that's how we get those points. So when it says graph, you just plot those ordered pairs on your coordinate plane. Remembering that positive x's are on the right, negative x's are on the left, positive y's are up, negative y's are down, and you can plot those points on your axes. That'll be the graph for that example. For a mapping, it's just a circle for your domain. Those are your x values. So these, domain is x, range is y. You plot all the x's, all the y's, then you draw an arrow to the ones that go together. So if we go back, we saw here when x was 4, y was 3. So in our mapping, we draw an arrow from the x circle over to the y. 4 and 3 go together. We have another x, -2 goes with -1. And we had two different x values that both had a -4 for y. So we just draw the arrow to the ones that are going together. So that's our mapping. Those are three things they asked for in that example. 1b. We're asked to determine the domain and range for this relation. Now, if we remember a little bit of vocab, domain just means x. All the x values. So if I look here, 4 is an x value. Everything that comes first in your ordered pair is an x value. Those 4 are all our domain. Now our range is going to be all the y values. Range is y. And if I circle all the y values, it's just the second number in each pair. Those are your y's. So when it says determine the domain and range, well, it just wants you to list all the domain, all the ones in red, and then all the range, all the y values. So the domain is all those x's. We put those in brackets. And the range is all of our y's. Now notice since -4 came up twice, you only have to write it one time. So there's a y value here and a y value here. They're the same. You only have to write it once. You don't have to repeat it. So that's 1b. Okay, so example 2. we've got a little bit to write down. This problem is about climate. So we're looking at the difference between different climates. So in warm climates, the average amount of electricity used rises as the daily average temperature increases and falls as the daily average temperature decreases. Identify the independent and dependent variables for this function. So independent and dependent are words that we have to think about what they understand. An independent variable is something that it just is what it is, so to speak. It doesn't depend on anything else. It's going to be what it's going to be. A dependent variable changes based on something else. Something else is controlling how that thing acts. So we can think about, in this case, temperature is independent variable, right? The temperature can be up or down. That's independent, though. It's not. There's nothing else telling us controlling what the temperature is going to be. It's unaffected by the amount of electricity used. Temperature is independent here. Electricity usage, though, is a dependent variable because it's affected by the temperature. The amount of electricity you use depends on how hot it is, right? So right now in the summer, we're all using much more electricity because it takes a lot more electricity to run our AC when it's hot. So electricity usage goes up in the summer, it goes much lower in the winter. So electricity usage depends on temperature. That's our dependent variable. So that's just understanding the difference between those. We'll see some examples like that going forward. On to 2b. We see it says here the number of calories you burn increases as the number of minutes that you walk increases. Identify the independent and dependent variable for this function. So let's just write the first sentence here, the number of calories. Let's start there and write just that sentence. We know the instructions here so that you don't have to write that part again. Just go ahead and write that first sentence and then we'll identify these two variables. So the number of calories you burn increases as the number of minutes that you walk increases. So which one of those depends on the other? And which one is independent of the other? If we think about it, it makes sense that time is independent, right? So anytime you see time, it is always going to be the independent variable. Time doesn't depend on anything else. Time is just time. Now, in this case, the number of calories you burn is dependent on how long you're walking, right? So the longer you walk, the more calories you burn. So the number of calories has to be the dependent. The time, though, is always independent, right? We don't control time. Time just goes on its own. But the number of calories depends on how long you exercise, how long you walk. So those are those two variables. Moving on to example 3. We're looking to analyze this graph. So we've got temperature on our y-axis, time on our x-axis. We want to look at the graph that represents the temperature in a classroom on a winter school day. And let's just describe what's happening. So for this one, you just jot down, describe. The directions are describe what's happening in the graph. So for this, let's look. We see the temperature is going up. As time is going along, the temperature goes up. It drops, up, drops, up, drops. So it's going back and forth, back and forth. And then it reaches a point where it just plummets and goes down over time. So in words, we want to analyze this graph. And you could say something along the lines of this here. It doesn't have to be exact, but something like the temperature increases as the heat is turned on, because we're talking about in the winter. Temperature goes up. Then the temperature fluctuates. It goes up and down, back and forth. Finally, the temperature drops when they turn the heat off. It gets cold again because it's wintertime. The temperature goes up, fluctuates, and then goes down. Something like that is what you need to say when analyzing these graphs. So for 3A, you need to have something down like this, describing this picture. And that's all you need for 3A today. 3B, this graph represents Macy's speed as she swims laps in a pool. Same thing though, we want to describe what's happening in the graph. So as we look at this graph in words, what is happening? She's swimming laps in a pool. Her speed over time goes up and goes down. It increases and goes down, increases and goes down. So it looks like her speed is definitely not constant. So C is wrong. Her speed doesn't continue to decrease. It goes up and down, so D is wrong. I'm not even sure what exactly they mean by Bob's. But if we look at B, her speed increases as she crosses the pool, but then decreases to 0 when she turns around at the end of each lap. That makes sense, because as we see here, this point goes down all the way to 0. Her speed is stopping for some reason, then picking up, reaching a maximum, slowing, then stopping again. So the only thing that makes sense is that she must be stopping to turn around and change directions. So in this case, the solution must be letter choice B. Her speed increases, she stops to turn around, then it increases again, so it's going up and down. So that's all for today. We should move on to our assignment at this point, understanding how to analyze graphs and how to do mappings in today's lesson.